Now that we have defined the problem, we can begin to solve it using Python. In particular, you can see in this folder the Python projects folder, in which we will define a new project which will be called, in a general way, insurance. Inside the insurance repository, we will save all the files, the Python files that we will use to develop this project. This project will be very simple, and in fact we will use just one Python script. But in order to write this Python script, we will use an IDE software. In particular, in the course of these courses, in the following courses, we will use the VS Code editor. You can install from the Microsoft website, since it is a Microsoft free product. And once you have installed it, you can right click on the folder and select the Open with Code. This is in Italian, but you will see open with the string with Open with Code, and this will pop up to you. This is the first thing you will see entering inside Visual Studio Code. We are in the insurance folder here. The Visual Studio core code is structured in several tabs. On the left side you can see the different things you can do with Visual Studio Code. You have the Explorer, in which you can see the open editors, all the files you have open, the insurance, which is the folder, and below it we will find the files inside that folder. We have the search function. These are functions that we will see maybe later. And finally, this is the extension tool that Visual Studio Code deploys to us. In fact, in Visual Studio we can install some extension to simplify our tasks when programming. For example, we have the extension of Docker, which is useful when working with the Docker. We have the Python extension, which we are forced to install when working with Python files, because in this way Visual Studio Code can reason about your code, tell you the errors and some other things. We have then the remote containers. You can see this by clicking, which tell us that through this extension we can work from our computer using a remote server. We write the code in this local machine, but we will run the code in the server, and so on. The extensions can be found by searching in this box, and also you have for example, the installed, recommended, enabled, disabled. You can search also by, for example, recommended, and so on. Another particular extension is the Git Easter Extension. Very good build. This is done by this guy. It's not a product developed by Microsoft. For example, by clicking on his name, we get every extension that are made by have been made by this publisher. The Git Easter extensions allow us to keep track of all our Git commits, and in this way our lives will be simpler with using versioning software. Since this project is quite simple, we will not use Git. So to begin the coding part, we will move, as you can see, once we click on every single thing in this left bar, a tab would appear here. So now we are in the insurance folder, and we want, first of all, to create a virtual environment that we will activate, and then we will use to program our software. I prefer to create the virtual environment inside Visual Studio Code, because in this way the IDE immediately identifies a new environment and selects the Python that is embedded inside the virtual environment to execute the code. In this way, in Visual Studio Code, we will not only write the code but also run it. Since inside Visual Studio Code there are embedded several terminals. So we can get the terminal by, for example, clicking here. We get the problems, we don't care, and we have the terminal, this other section. Here I have selected the bash terminals, which is one of the Linux terminals. You can use the PowerShell on other terminals by selecting the default shell. I use bash because I mainly program in this local machine, but using some sort of server in the cloud. So I need to run, I prefer to run commands only in the Linux language. So to create a virtual environment, we are, as you can see in desktop, Python projects insurance. So we have installed on this machine the Python version 3.9. The pure Python. We don't have, for example, a set of libraries like in the Anaconda package. Here in this local machine we have just Python 3.9. So when working with some libraries, we will install those libraries inside the virtual environment to keep the main Python version in this machine clean. We can then create, let's create then the Python virtual environment by running python.m, as we have seen in the previous course, venv, and we will call this virtual environment simply venv. So this will create the environment, and as you can see, the folder has been created. We wait a minute. As you can see here, we have on the left side, we have the tabs about the Explorer, the extensions, and so on. So we can see the files and the folders inside our main folder that we opened with the Visual Studio Code. Then we have on the bottom right, we have the terminal, the problems, which is a tab in which we will see the problems that are identified by the Python extension, for example, in our code. We will have the output and the debug console, which we will not cover in this course. So the virtual environment has been created. Now, since this is a terminal, we can run it. Also, I don't know why in this case this didn't happen, but Visual Studio Code can identify the virtual environment inside the folder in which we are programming, and in this way you don't need to define anything. It will automatically, once the Python has been a Python file has been opened, it will automatically identify the virtual environment. Let's see if this works if we define a Python file. For example, we define a new file which will be called let's call it insurance again, maybe prices, that's better. we define the .py extension, and we open the Python file. All right, no, here we go. Is searching a Python version, and in fact, it asks us which Python interpreter do you want to use. No Python interpreter is selected. You need to select a Python interpreter to enable features like linting and debugging. So let's select a Python interpreter. We have the Python 3.9 version that is the default in our machine, and the Python 3.9 version inside the virtual environment. Of course, we have created this virtual environment just to program through this file. Then we selected the venv, and automatically you can see that a new folder has been created, the .vs Code. Usually, especially in Linux machine, folders that begin with dot are hidden folders. And inside the VS Code you find a JSON with the settings, and the settings say that the Python path is the Windows, the venv scripts python.exe. So in this way, the Visual Studio Code understands which Python use. Probably when we will reopen the Visual Studio Code in the same folder, Visual Studio Code will search for the .vs Code folder, will extract those settings, and automatically load the virtual environment. Since we are still in the same terminal, Visual Studio Code did nothing for us right now. So let's activate it by running. We are in a bash shell, in a Linux shell, so we will run source, then we are venv scripts, and finally activate. Here we have we are inside the virtual environment. In order to do so, to be able to see if everything works as intended, we will run our first Python script, which will be a print hello world. So we invoke the print function and say hello world. To run it, we can say python prices.py, and here we go, we obtain the hello world string, and this is one thing. You have also the button run here, run code, which does the same. So we have defined our virtual environment, we have saved our first Python and executed the first Python script. We have set the Visual Studio Code interpreter. Now we can begin to program. The first thing we will do is to define the products which the agent sells to the client. We will start by we will code one property product and one motor product. One motor product that each of them will have inside them two guarantees. So we have to write a comment in Python, we use this symbol, the hashtag. So we have that the product is let's start by this. We have the guarantee, which is embedded inside a product, and then we will maybe have the product portfolio catalog. So we will start by coding the guarantee, then we put the guarantee inside a product, and the product each product inside the product catalog. Let's start by defining then a property guarantee. For example, the fire guarantee, in which this insurance guarantee protects us from the house getting damaged from fire. The insurance guarantee could have many properties, but to simplify things, we will define just two properties per guarantee: the name and the price. And again, to simplify the things, we will define the price as a fixed amount. Usually in insurance, the price is proportional to several risks that the insurance company considers to price that guarantee. For example, the price for a fire guarantee could depend on how big is your house. So, which data structure could we use to code a guarantee? And we have seen that the guarantee would have a name and a price. Well, we can use a dictionary. So let's start by defining the fire guarantee as a dictionary. And in order to define a dictionary, we will write something like this. Now we will define the two properties of a fire guarantee. Usually I prefer to write things inside a dictionary in several lines. So we'll have the name of the guarantee, which will be fire guarantee. I put a comma in there, and the second property, second element on the key value element of the dictionary will be the price. And the price, for example, will be 10.1. Usually, when writing a dictionary, a list, or something like that, using multiple lines, is the better way to code it is to put a comma after each line of code. This because if I want to write another property, I just have to press enter and code the things. And I don't, in this way, I will not incur in the error of forgetting about the comma. Alright, so this is the fire guarantee. We will define another guarantee for the property product, which will be the earthquake. The earthquake guarantee. Okay, I finally made it. Again, we have the name, which will be earthquake. And the price. The price will be lower than the fire guarantee because usually, for example, $2.3, because the odds of an earthquake are very low, and usually the damage incurred when an earthquake happens doesn't completely balance the odds. That's why, for example, the earthquake guarantee costs less than the fire guarantee. And this is one product. The other two guarantees that we will define will be used inside the motor product. So we will have the third-party liability guarantee, which will have again a name and will be third party liability, and finally the price will be, for example, $203. We define the last guarantee, which will be the own damage guarantee. So if we damage other vehicles, the third-party liability guarantee protects us, but if we damage our vehicle, then the own damage guarantee will cover us. So again, the name, the own damage cover, and then we will have the price, which will be set as $56.1. Okay, so these are the 4 guarantees. But you can see that everyone could define a guarantee in whatever way he wants. Because, for example, just by mistake, he could put the key as the value and the value of the dictionary as the price string, for example. So this could be misleading. That's why I want to introduce you a library which is pre-installed in the Python standard package, which is called typing. And typing helps you to define some type ints, which are only ints. We do not force anyone in Python to write things in the format we want. We just type hints that will help us to define how a guarantee should be written. So you can see that a guarantee is actually a dictionary. So we import our first library, which will be from the typing library. We will import dict, which means this dictionary. It means that we are intending as a dictionary. And a guarantee in general is defined as a dictionary of something, and inside this parenthesis we will define the format of the key and the format of the value. For sure the key will be a string, but the value could be a string, a floating number. So in order to express this thing, we will define first of all another type, which will be the guarantee feature. And the guarantee feature will be a type variable. As you can see now, the VS Code helps me and says, do you intend a type variable? Yes, I do. And what does it do? It also imports this is an object, imports the object for me. In this way I don't make mistakes. So it's a type variable. Its name will be the same as the guarantee feature. Excuse me, this is, we use the round parenthesis. And the guarantee feature could have the string format or a float format. And now I can write like this. So we have defined that the guarantee feature, a new type of variable called guarantee feature, and the guarantee feature could be either a string or a float. In this way, the guarantee type is defined as a dictionary where the keys are strings and the values are guarantee features. This is very helpful, but we still don't have a link between the guarantee and all of these guarantees that we have defined. To do so, we just explicit this link by writing this little code here. So we are saying that file guarantee as a type guarantee and as a value like this. Again, the same is for the earthquake guarantee, the TLP guarantee, and the own damage guarantee. We are specifying that these four dictionaries are guarantees and have this type. They are a dictionary of string guarantee features. As you can see here, I have no problems. The Visual Studio Code did not detect at all problems in our code. But what if we write the file guarantee in an improper manner? For example, we write 10.1 as a key and the value is price. As you can see, no problems are detected. In fact, this syntax is actually valid, but it does not respect what a guarantee is. In fact, we are talking about typing ints. To detect those kind of errors, however, we can use the MyPy Python library. In order to do so, we move to the terminal and we will install inside our valve, we will install through the pip command the MyPy package. Excuse me, oh, I forget about the install command. MyPy. Install MyPy. Running MyPy on this code will detect this improper definition of guarantee. Here we go, it's collecting, successfully upgraded. So let's clear command. Alright. Now that is installed and we are on the virtual environment, we will run simply mypy on prices.py. Let's see what we get. It's actually running. Takes a while, we don't know why. Here we go, one error found, one error in one file. And it says error on line 8, here we go, on line 8, dictionary, because guarantee is a dictionary, as entry 1 as incompatible type float, because expected string as a key, any, in which any is a string or float, as value. So MyPy detected this syntax error. So let's just solve this mistake. Okay, we have finally defined the guarantee. Now the product should be very easy. And in fact, the product will be a collection of guarantees. And the data structure that we can use in Python to describe a collection of things would be a tuple or a list. Usually we prefer a list, since in this way elements could be mutable. So let's begin by defining here on top what a product is. The type of product will be just a list, and you can see automatically Visual Studio Code imported the list object from the typing library. Is a list of what? Of guarantee. Fine. So we have to define the property product here, and we can do this straight away here. So property product will be a list of what? The fire guarantee and the earthquake guarantee. That's it, simple like this. Except for the fact that we want to specify that the product is actually as a type, the product type. The same we do with the motor product. So motor product will be defined as a list of what? Of the third-party liability guarantee and the own damage guarantee. That's it. We have already defined the two products. Now that we have defined the products, let's just wrap it up like this, so we can see everything together. We have the fire guarantee, the earthquake guarantee that together build the property product. We have the third-party guarantee, the own damage guarantee that together make the motor product. What are we missing? The clients. So we suppose that the agent would sell a product, a property product, a motor product, or both to a client. So in order to describe a client, we have again to use a Python data structure. Again, a client could have a lot of properties. The name, the email address, for example, the address itself, the age, and so on. So right now we will use only two properties, the name and the age. So for example, let's first define the, maybe let's put a comment here. Property is a property product. This is a motor product. And here we will define what? Clients. Let's begin with the first client, and then we will replicate the same process of deriving the type that we can assign to our clients. Our first client will be Anna, and as mentioned before, we define her name, Anna of course, and we will also define her age. Right now we will make use of the age itself, not the birth date, and then derive the age. This is to make things even simpler. We have Hannah, we have John, which is a little bit older. We have name, which is John. His age is 65 years old, 75 years old. We have finally our third and last client, which will be Sarah. Her name, of course, will be marked as Sarah, and she is middle age, which means 42 years old. That's it. Fine. So again, clients are described using a data structure, which is a dictionary. So we can do the same thing we did previously. Let's define the client type, which will be a dictionary of what? A string, of course, and something that could be a string or an integer, because we round up the age as integer. So we made the same thing, client feature. Let's always call it feature, which will be a type variable. We define a new type variable. Again, the name will be client feature, and the values of this dictionary could be string or integer. Then we copy paste the client feature down here. We have defined the data structure of a client. Let's check is everything is written in a proper way by running again mypy. Success, no issues found in this file. Fine. Let's continue then. Now we have to define our client portfolio. Maybe let's move this, let's do something like this. Let's move everything here. Maybe we'll do products, types, and here we do clients types. Okay. We have defined the clients, now we have to define the client portfolio. And the client portfolio is just a collection of clients, which means that the clients portfolio will be a list of Anna, John, and Sarah. Client's portfolio is a list, so let's tell them that the client PDF is equal to a list of what? Of client. I forgot here to type the type, so we run this on fly right here. Okay. To write in Visual Studio Code, to write on multiple lines, you just keep press the Control button on your keyboard and then select other things, and when typing, then when you stop pressing Control and you start typing, you are actually writing things in each selection contemporary at the same time. So client's portfolio is just client portfolio right there. Okay, this part was a little bit boring, but we have understood what are the first thing we can do with typing and how to use data structures and to write them in Python. Now let's begin doing something a little bit more sophisticated. In particular, after defining the products and the clients, we have to begin to assign the products to each client and to compute the total price owed from the clients to the insurance agent. So what we will start doing this by looking at clients portfolio. So from clients portfolio, we would like to take each client, from each client assign the products, and from the products compute the sum of the prices. What we intend to do is a loop. And in particular, we can describe this process using a for loop. The for loop is written in this way. To solve this problem, for client in client's portfolio, and then this is the things you could do. So we are selecting here a list, an iterable, and we are saying that take one argument at a time of this list, name it client, and then do these things. And of course it will take Anna, John, and then Sarah. For example, let's write it down. For example, let's print the client here to see what we are gonna do. Of course, we will get first Anna, second John, third Sarah, but each of these clients has several properties, so Python will present client as a dictionary. But let's see what it prints out. Here we go. So, in the first step, it told us this is Anna, second John, and third Sarah. But now we have to, inside this for loop, we can assign the product. Also, now we can access to a pair of key value of a dictionary by typing, for example, the key. If I type client, which is, we have already seen that is a dictionary since it's a client. If I type here in this manner name, I will get the names of the three clients, Anna, John, and Sarah. With this in mind, we want to associate products to clients, and in order to do so, we will use the age as a discriminator between the different products and guarantees that a client will select. So what we want to say is, if the age is above something, then that client would buy these products. Then if this client has an age between this value and this value, will buy another product, and so on. We are describing an if condition. So we are saying that if the client, for example, the age is above 40, then the client will probably have bought a house and a car. So he or she will probably buy the two products, both of the products. But if the client age is above 70, is greater than 70, well, maybe it doesn't drive anymore. So let's define a new inside the client dictionary. Let's define a new key, which will be the insurance products, and will be a list of what? If this client will have more than 70 years, then it will have the property. It will buy only the property product. But if the client is older than 40 years old, but has less than 70 years, well, the client will have a car and a house, so he or she will buy both of the insurance products. So else, you can see that here we have the if condition and the else condition that describe this condition. Is this true? Okay, then I go inside here. If this is false, then I go inside the else statement, and inside the else statement we are saying just that the client insurance products will be what? Will be the property product for sure, but also we type plus motor product. So what will be insurance products? Well, insurance products will be a list, because a product, if you remember, is just a list of guarantees. And we can, by summing two lists, we are just creating a new list with the elements of this list and the elements of the other one. So this client's insurance product will be a list of 4 elements, because each product has 2 guarantees, remember. Now we can run the last else, and then to tweak a little bit this a lot of if statements. So what if the client is younger than 40? We run else. Well, probably the client will have bought already a car, but maybe not a house. So the client will just buy a motor product. Like this. Now let's start to optimize these if statements. We can, for example, do something like this. We can start from the age of 70. Let's move it out here. Okay. So to comment a lot of lines, you can select all this line and tap 3 times this symbol, and you will see that it will get, this is all commented. This is just a comment. So let's run this. So if the client has this age, then it would buy only. Okay. If the client, this condition is false, but the client has less equal 40 years old, or let's keep it as more than 40 years old, then so we write we want to do an else and then an if. So we just write elif and the condition. So the client age of 40. And we do the things here. Why we are sure that if this condition is true, we are referring to a client that has an age between 40 and 70? Well, because we are in the condition in which we are in the elif statement in which this condition is false. So we are sure that this is false, and we are asking if this is true, you do this. Else, you will do that. So what if, what we do if, what the client does if her or his age is between 40 and 70, the client will buy both products. If we are in this else statement, it means that the client is not more than 70 years old, and not even 40, is not even 40, so the client will just buy the motor product. This can be deleted. As you can see, we are wrapping up this into these two if statements can be written in a more compact way. This is a tab mistake. Here we go. A more compact way in this sense. Also note that in the insurance product now here is a list, so we have to update here, and we have also to say that the client's feature is also a list. Let's say if for him is everything fine. Let's run mypy prices, no issues in fact, because we are specified that the client feature that goes inside of the client dictionary could be also a list. Very good. So we have finally assigned products to each client. Now let's print if this is what we expect. For example, we print right here the name of the client name, we have said the name and the client insurance products. We can write this down with a comma in here, so we get the print of this and the print of that. We can also specify a separator, which will be a tab, so we make things a little bit pretty clear. We run our Python prices, and as you can see, we get that Anna gets third-party liability, which is a motor, and gets own damage cover, and that's it. And Anna was 25 years old. She's young, so she only has a car, not an house. And in fact, we find here, we find here only the guarantees that are inside the motor product. And John is a little bit older, in fact is 75 years old, and the guarantees that he bought are referred only to the property product. Finally, looking at Sarah guarantees, and Sarah is 42 years old. The guarantees she bought are refer both to the product, the property product, and the motor product. In fact, we can see that name, fire, earthquake, third-party liability down here, and finally the own damage cover. That's fine. Now we finally I would like to compute the total cost of the products that the clients bought. We will use the function sum that is embedded in the Python standard library, which takes a list of numbers, floating or integers, whatever, and the sums of the items and returns to us the sum, of course. So let's define a new variable, the policy cost, which will be the sum of what? Functions do want this parenthesis as the print one. So we have to give to the sum function a list. A list of what? The prices of each guarantee inside each product that the client bought. So remember, we are inside the for loop, so we are referring to a generic client. First will be Anna, then John, then Sarah. So what we would like to do is to just write something product, a list of product price, where the product price will be each of the products inside inside maybe the guarantees, excuse me, the guarantee price for each product and for each guarantee that the client bought. We are referring another time to a for loop, and Python allows us to write also for loops in a straight line just by writing guarantee. What is a guarantee? Well, guarantee is a for guarantee in what? We are client is products. So we are looping through, looking at only this, what we are saying. We are looping through each guarantee inside the insurance products for that client, that particular client. This guarantee will have a key value, price, and since this code is written in as a list, it means that take each element of the guarantee, select the price, and put this inside a list. We can see this by printing it. Let's print the policy cost. Maybe let's first give up the sum right now. We write this as policy cost, whatever. So adjust the name here. Let's run. You can see that Anna and the policy cost is 203.56.1. So the first element of this guarantee price is the $203, the third party liability price, and this 56.1 for the own damage cover is written also in there. Same for the other two clients. As you can see, Sarah also has 4 prices because she bought 4 guarantees. This is very powerful because it allows us to write simple for loops in line. Now we can write some of this thing to make it look at better. I prefer to write this down. So we are doing a sum of this list, and this list is computed using this for loop. We have finally derived the policy cost. Now let's print the results in a beautiful way. So let's get rid of this. We have our policy cost, so we want to explicit that the client name has to pay an X amount of dollars for how many products or how many guarantees. So let's use the print function, but we will use the fstring method to write a string which will be printed in our terminal. So we type f before the string definition, and using this parenthesis we will define the variable we want to print. So we will want to print the client name. This is the client name. As you can see, this goes in conflict because we have to use these other symbols. Both symbols are identical, but if you put this symbol here in here, the Python understands as this is only a string and then interrupts it and does errors. That's also why we are able to get these two symbols to describe a string. So the client has to pay which amount? Well, the policy cost. This amount of dollars for how many guarantees? The length of the client insurance product. Let me select and go toggle wrap. Okay. Again, I made a mistake here. Whoops. Okay. Here we go. So here we have clients. Okay. Maybe if we write it in this way, it would be better. A little bit, not that much, but it's a little bit more pretty. So we print the name of the client, then we say has to pay policy cost, the value of policy cost, the dollars, for how many products, how many guarantees. Excuse me, this is guarantees. The one and the number of elements inside the list of insurance products, and we type in there. But also we would like to write policy cost, the cost of the policies, using rounding by 2 decimals. We can do this by formatting the values by typing in .2 f because it's a float. So let's move right here. Clear things. We run prices and we have Anna has to pay this amount of dollars for 2 guarantees. And Sarah, which is the middle-aged one, has to pay this amount of dollars for 4 guarantees. As you can see, the amount has 2 decimals. If we get rid of this small code, we will get no rounding. So let's make things pretty clear here. And as you can see, right now since we have used make use of an intensive use of the for loops. We could have done something similar using also another loop, which is the while loop. So if we comment all these things, let's not comment, let's see briefly a way we could have written this code. So the while statement means that while this sentence, for example, sentence is true, while this sentence will be true, then you do this. If this is not true anymore, you pass through this statement. Otherwise, you keep looping through it. So in this problem, we could define a new list that we could call potential clients. So these are the people who come to us, and we want to define which products can be sold to them, and also how much all of that guarantees would pay. So the potential clients will be the client's portfolio in this way. And we say that while potential client has at least one element inside it, so the length of this list is greater than 0, then you do something. We are doing something, but first of all, we need to drop for each cycle through the while loop a client from potential clients. Otherwise, it will keep looping forever. And also, we want to extract that client so we can compute, for example, the policy cost. In order to do so, we make use of the function pop. So we take the potential clients and we write pop and the index of the element of the list we want to pop. Pop means that we remove the zeroth, which is the first element of the list, but also pop will return that element to us. So we can write client equal to potential clients pop 0. So since potential clients is equal to clients portfolio, and clients portfolio is made by listing Anna, John, and Sarah, we'll get here that at the first loop, the first cycle of the while loop, we will get potential clients as length 3, so is greater than 0. Let's enter inside the while loop. We do the pop of 0, and right now the pop of 0 is Anna. So in the first step, we get that potential clients will be Anna, John, and Sarah, right? So with pop0 we are extracting Anna, but also removing from this list. So at the second run, potential clients will have only two elements, John and Sarah. So the length of potential clients is still greater than 0. It's not empty. So let's pop another client, John. We do a third run. In which we have only Sarah. We pop that client. We extract this Sarah, but at the fourth run we get that the potential client is empty. So don't go inside the while statement. For example, here you can see that we can do print. We can print the client name, for example, and let's keep it like this, the client name. So moving on, let's do this. We do Python prices, and we have, this is what comes from the for loop, and from the while loop we get Anna, John, Sarah. We could replace this for loop by copying and pasting this code here. So doing something like this. This would be an alternative solution. So this is it. We have finally coded our first Python script, and we have seen how to describe objects using simple Python data structures. We have discovered the while and the for loops, and also the if-else state condition. As you can see, as you may have already noticed, these data structures are very useful, but are not rigid. For example, if here I may by mistake type wrongly the age key, the Python interpreter would search, for example, for age 11 key, would not find it, and the code then breaks. The Python will report us an error. Also, two developers could write dictionaries in different ways. For example, we have seen name and the name, age, and the integer, but maybe someone could write this as integer age to specify the fact that the age is rounded, and then this code would break again because age does not exist anymore. So in the next course we will analyze a new and how to leverage these concepts through the object-oriented programming, defining and making use of classes and functions finally. So take care and keep practicing with Python. Bye.